So class, we continue to the second part of our tutorial today. We have 3.4 electromotive force, internal resistance and potential difference. So first, we want to distinguish what we mean by electromotive force, EMF, and terminal potential difference, V. So let us consider a circuit that we consist of battery that is connected by wire to an external resistance R. Okay, as shown in this figure. So I have a battery, and this battery have internal resistance. I denote by small capital R. Okay, so this is external resistance. So the resistance that exists inside the battery, I call it as internal resistance. Resistance yang wujud dalam battery itu sendiri, I call it as internal resistance. Okay, so I have a battery with internal resistance R. I connect it to an external resistor, capital R. So what is meant by EMF? So EMF, electromotive force, EMF, is the energy that we provide by the battery or the cell to each unit of charge in order for the charge to move through the external and internal resistance. This one, so the energy that we provide for the free electron to move through the internal resistance and also the external resistance. Okay, and that one we call electromotive force. Clear? Okay, then what is terminal potential difference, or we call it as terminal voltage, V. So terminal voltage V pula, maksudnya apa? So the terminal potential difference voltage is referred to the work we done to bring a unit of the charge from negative to the positive terminal of the battery only through the external resistance. Okay, so terminal potential difference means the work we do to bring a charge from the terminal negative of the battery moving through the external resistance and then until the positive terminal of the battery. That one we call terminal voltage. Maksudnya voltage antara dua terminal battery yang across external resistance only. External resistance only. Okay? So voltage that across the external resistance only, that one you call terminal potential difference. Kalau electromotive force, that one is the voltage across external and internal resistance. Yang lalu external dan internal sekali. Jelas? Then class, be careful. Even though we have a wording force here, but EMF is not a force at all. It's actually is potential difference. That's why I said electromotive force is the potential difference that pass through the external and also internal resistance. If terminal potential difference, that one only external resistance only across external resistance. So nampak perbezaan dia. Kalau EMF, that one internal dan juga external. Kalau terminal voltage, that one only pass through external resistance only. Okay, so if I have a battery with internal resistance R, so I will find out that the EMF of the battery will be the voltage across the internal resistance. So voltage is current multiplied resistance daripada Ohm's law. Kalau ikut Ohm's law, voltage adalah current darab resistance. So, tadi kita dah kata EMF adalah voltage yang across internal dan juga external. So, EMF adalah voltage across internal resistance and tu maksudnya plus lah. Voltage across external. So, macam mana nak cari voltage across the external? Macam nak cari voltage across this external resistance? So, mestilah current yang lalu darab dengan nilai resistance dia. So, it will be I R. Okay? And then, ikut definition just now, I R ni lah apa? I darab R, that one is the voltage across external resistance. So, yang across external resistance tu kita panggil sebagai terminal voltage. So, I will going to have EMF is IR plus V. So, ataupun susun balik, you dapat V adalah EMF minus IR. That's why we will find out that when current I flow naturally from the battery, there will be an internal drop in potential difference or voltage that equal to IR. So, bila current flow keluar dari bateri, sebahagian voltage telah diambil oleh internal resistance. So, yang pergi kepada external akan jadi kurang lah. So, kita dapati the terminal voltage V will always less than EMF. Why? Because of the internal resistance. See? Sum is given to the internal resistance. Okay? So, the terminal voltage V will be the EMF minus the voltage drop across the internal resistance. Okay, so the unit for terminal voltage and also the EMF is volt. Dua-dua tu adalah potential difference. IR ni adalah voltage that drop in the internal resistance. So, maksudnya, bila kita sambungkan bateri dan provide current kepada external resistance, kita akan dapati sebahagian voltage akan drop melalui internal resistance, selebihnya baru diberi dan ataupun diambil oleh external resistance. Okay. So, the terminal voltage V hanya relate dengan external resistance I, R. So, I is referred to the current that flow in the circuit lah. R is the total external resistance lah sebab terminal voltage kan. So, R ni mesti refer kepada external resistance. So, kalaulah saya ada satu bateri 3 volt, internal resistance 1.5 ohm, I'm going to connect to external resistance 4.5 ohm. Tapi saya ada switch dan saya connectkan satu voltmeter across the terminal of the battery. Saya sambungkan satu voltmeter across the terminal of the battery. Then we might ask, what is the reading of the voltmeter? It will measure EMF or it will measure terminal voltage. So, voltmeter tu measure apa? EMF ke terminal voltage? So, it depends on whether we have current or not in the circuit. I repeat, voltmeter ni measure EMF ataupun terminal voltage. It depends sama ada circuit kita tu ada current ke tidak. Okay, so if our circuit is, our switch is open, okay, if we have switch open macam ni, the switch is open, so we are going to have open circuit. What is mean by open circuit? Open circuit means our circuit is not complete. Our circuit is not complete. Highlight sampai sini. Terputus, tak sambung, tak tersambung. Dia terputus dekat sini. Okay, so that one we call open circuit. So if we have open circuit like this, then we will find out that our current is zero because there will be no current flow sebab it's an incomplete circuit. It's an incomplete circuit. So our current is zero. So when our current is zero, what are measured by the voltage, voltmeter? So the voltmeter will read the EMF. Okay, the voltmeter will read EMF. So how much is the EMF of the battery? 3 volt. For example, for this one, 3 volt. Okay, then in what condition our voltmeter will measure terminal voltage? In what condition our voltmeter will measure terminal voltage? Providing that our circuit is closed. If our switch is closed, we have a complete circuit. We have a complete circuit. We have a complete circuit, and the current flow in the circuit. Okay, current flow in the circuit. So when current flow out from the battery, some of the voltage is dropped through the internal resistance, and then only the rest of the voltage will be taken by the external resistor. So at that time, our voltage will measure, our voltmeter will read terminal voltage. Okay, our voltmeter will read terminal voltage. So how I know what is the value of the terminal voltage? So first I can calculate the current first from the EMF, relate the EMF with the resistance, external and internal. We find the current, and then the terminal voltage will be current multiplied the value of the external resistance. So for example, this one I have 3 over 4.5 plus 1.5. So I'll get the current will be 0.5 ampere. Then the terminal voltage will be 0.5 multiplied the external resistance 4.5 ohms. So I'll get 2.25 volt. Okay, so apa yang teacher nak tekankan di sini ialah apa yang akan di-measure oleh voltmeter yang kita sambung across the terminal of the battery, dia bergantung kepada sama ada wujud ke tidak current dalam circuit tu. So sekiranya anda ada open circuit, so because if you have open circuit like this, incomplete circuit, then you will measure the EMF of the battery. Okay, if your circuit is closed, when your circuit is closed, it's a complete one. See, it's complete. It's a complete circuit whereby the current flow in the circuit is a complete circuit. The current flow, and that time you will measure the terminal of the terminal voltage of the battery. Okay, I repeat, if your switch is closed, current is flow in the circuit, then we will measure the terminal voltage. Clear? Okay, so this is the difference between the internal the EMF and also the terminal voltage. So most of the battery, they have their own internal resistance. Okay, unless I say the internal resistance is negligible. Okay, so sometimes normally battery mesti ada internal resistance, dan nilai internal resistance ni akan bertambah bila battery tu usia dia, tempoh kita guna battery tu makin lama, dan nilai internal resistance ni akan makin besar. Okay, so itu maklumat tambahan lah untuk you tentang internal resistance. Okay, then this is the concept we have for subtopic 3.4. Then we will move on to practice the concept using tutorial question 5 and 6.